Bering Land Bridge National Preserve protects, among other things, one of the most unspoiled barrier island and lagoon systems in North America. While much is still unknown about the lagoons, they are considered important wetland habitat for both marine and terrestrial life. In many parts of the world, barrier islands have been developed for their recreational and tourism values, often causing significant impact to their natural ecology. The opportunity to preserve and study an unspoiled barrier island system is rare. Taze Jones, an ecologist with the National Park Service, has been working to better understand these unique lagoons.
Well, a lot of times the lagoons will function as a nursery area for the biological pieces of the system that are outside in the open ocean. So what you'll often find, or what that means, is that you'll often find juvenile fishes, juvenile, snails, all kinds of different juveniles in the lagoons that you typically won't find out in the open ocean because it's a big safe harbor for them.
This safe harbor, however, is not immune from the potential impacts of increased industrial activity. As changing climate results in longer periods of ice-free seas in the Arctic, shipping activity has increased dramatically.
In the last several years, there's been a significant increase in shipping coming through the Bering Strait. The lagoons act as sort of a back catch area for what happens out in the ocean. And so if, for instance, there's an incident with shipping or, say, an oil spill or something like that that happens, we just want to be prepared.
To that end, Jones has been working with National Park Service hydrologist Paul Berger to better understand how the lagoons interact with the open sea.
The lagoons are actually fed by several major rivers that come in, and there's very few outlets from these barrier islands. So we're trying to understand the dynamics of how the water moves into and out of these lagoons, both the freshwater and the ocean water.
Understanding the movement and flow of water will help park managers predict which parts of the lagoons are at highest risk from any impacts coming from the open sea.
And we really need to understand how we could actually protect these lagoons if there is a spill. I mean, is there a place that we could put up booms where we could capture most of the material coming in? Or is it a case where there's so much fresh water coming out that it basically would keep stuff away from the coast?
So to try and understand, it's kind of broken down into a couple of different parts. The first part of doing it is we place these little instruments called level loggers in the water. And what the level loggers do, quite simply, they just measure the amount of pressure that's put on them. And so as the tide comes in, the water level goes up, that increases the pressure on the instrument, and so it records that and tells us basically when the tides are moving and when they're cycling through. And that is the first piece of the puzzle. Then the next piece of the puzzle is to try and know how much water is coming in and out.
The way that we measure the flow is we run what's called an acoustic Doppler coupled profiler, which is basically a fancy way of saying we use sonar. And basically it's an instrument that we tow along either by hand or in a boat, and in the case here we have to use a boat because the water is so deep and the channels are so wide. But it basically sends out sound waves, and those waves bounce off of the particles in the water.
And as it's listening essentially to the water, it can hear how fast the water is moving. It can also tell how deep the channel is that we're monitoring.
This data will allow Berger to calculate the volume and velocity of water entering and exiting the lagoon at various points in the tide cycle.
The other part of this, which is really particularly important, is that in the seasonal migration of birds in and out of the Arctic, this happens to be both a breeding ground and a fairly significant feeding ground, and the lagoons provide a significant portion of that food supply for a lot of the birds that are coming through.
You're looking at a very sensitive environment in the Arctic to begin with. Looking at an unspoiled barrier island system, you're just seeing one of these systems completely intact, completely functioning, has been pretty amazing.
There's not a lot that's known about these systems, and as we pull the pieces that are known together, it starts to fill in that puzzle and really helps us be able to know and understand and appreciate how amazing and wonderful these resources really are.